everyone says they're following, it's much more encouraging. So next time when I say, are we there? I hope everyone who is there can say yes or no, or maybe something like that. So yes, we are continuing on to solve some more examples under our topic, thermophysics, but talking mostly about ideal gases. So um, let us have Sante to read for us the question which is there on the board, on the screen.
A small balloon, partly filled with helium, has a radius of 18.0 centimeters, a spherical shape.
Okay.
Internal pressure is 1.05 atmosphere at 20 degrees Celsius. Find the number of moles of helium in the balloon and the mass of the helium. Molar mass is equal to 4 for helium.
Okay. So thank you very much for that reading. So we have a small balloon. So here they have used the word partly filled. So it's just that you know that a balloon is like that with an opening, right? With an opening where you blow air in. All right. So if they have used the word partly filled, it just means that they haven't fully inflated it, because if they had fully inflated it, probably the balloon would have had a much bigger volume. So it's just a small balloon. So partly filled with helium. It's not fully inflated to its maximum. So it has helium gas in it, and it has this radius, and it has pressure. So they have given us the pressure in atmosphere and the temperature in degrees Celsius. Find the number of moles of helium in the balloon and the mass of helium. So we know the radius, we know the pressure, and we know the temperature always has to be in Kelvin. So which formula are we going to use? So depending upon the formula that we're going to use, we shall either keep this value of pressure like this, or we might change it to Pascal. So we want to find out the number of moles that can have this information for helium. So first of all, we need to find the volume, because they just told us they just told us that it's a helium balloon with a radius. They give us a radius, but we need to find out the volume. So we know that the volume of a balloon, since they gave us a spherical shaped, so it's a sphere. So we know that the volume of a sphere is 4/3 pi r cubic. So you would need to know the volume of certain shapes already prior to just, as an university student, you need to know the volume of a cube, anything, almost any shape. You should be able to know a sphere, whatnot. You should know the volume for such. So 4/3 pi r cubic, volume of the sphere. And when we compute the volume, we find this answer. So from there now, we use the formula. Now, what formula we're using is this. Why are we using this formula? Because they said, find the number of what? Number of moles of helium in the balloon and the mass of the helium balloon. And the mass of helium. So to find the number of moles, we need to use this formula. Why? Because it has this value n. This n value stands for number of moles. It is the mass that we have over the molecular mass. All right, that's where the n comes from. Just a moment. I just rubbed something here. Yeah, this shouldn't be there. Okay, so Yeah, we use this formula because of this N. All right, because N stands for number of moles. All right, so if we use this formula, pressure always has to be in Pascal. Remember, the pressure that was given in what? In atmosphere. Atmosphere is also a unit for measuring temperature, pressure. So 1 atmosphere, 2 atmospheres, 3 atmosphere, pressure might be given in that way. So we need to make sure it is given in Pascal. So the conversion from atmosphere to Pascal is we just multiply the value that has been given in atmosphere, multiply by this value. So you need to have this value at your fingertips, because the value of 1 atmosphere is equals to about 1.01. Sometimes they just end at 3. Some 1 point. If you end at 3, it's still okay. Or you can even add to, 1.0132, just like the way they have given it. They have even added 5. So all in all, this is the conversion from atmosphere to pascals, 10 to the power 5 pascals. So is this the gauge pressure here? Here it doesn't matter whether it's the gauge pressure or not. All we know is pressure. If we are talking about gauge pressure and whatnot, then we add the pressure that we have been given. If we wanted to find the total pressure or anything like that, then we would have also added atmospheric pressure. But gauge pressure is pressure where they have not considered the atmospheric pressure. So if you have your total pressure and everything, you subtract atmospheric pressure, what you find is your gauge pressure. All right? But here, we don't need to bother ourselves whether it's gauge pressure or not, because here we just need to solve, to calculate. They have given us the pressure here, and we know the volume, which we have just from calculating. We know the temperature. Temperature was given. So what we need to do is to find N, this value of N. We know the volume, we know the pressure, we know the volume, we know the temperature. We also know R. R is the ideal gas constant. I'm sure you should be able to know the value of R by now. All right. So I didn't write it here, but maybe I can just write it somewhere else and say R, like we said, if I'm just calculating the number of moles, then my R is 8.314. All right. 4 joules per mole. Times Kelvin. All right. Even if you forget these units, as long as you know this number, 8.314. Sometimes they may give it to you. Sometimes they will expect that you know it. So some of these, try and master some of the constants, so you know that the constant R for an ideal gas is 8.314. All right, 8.314. You should be able to master that. If they said kilomoles, if in any of the questions they said kilomoles, then what you use is, instead of 8.3, you remove this point. So you multiply by 1,000. You multiply this value by 1,000, and then it will be 8,314. All right, if they said kilomoles. But here they have not said kilomoles. They have just said moles. So we'll just use this one, 8.314. So even if you have forgotten these joules per mole Kelvin, don't worry about that. all you need to know is this number here. So that when we are calculating for the number of moles, we make in the subject of the formula, we have PV over RT. We know our P, pressure, we know our volume, we know our R, and we know our temperature. Remember our temperature? We did 20 plus 273 to give us this value. And it's the one that we have. We have this pressure that we calculated, volume that we calculated, the gas constant, R, is here, the temperature is there. No wonder now here we're able to find the number of moles. Are we clear on that? How to go about it?
Yes. Yes. Yes,
Okay.
I'm clear on that. I have I think one question.
Okay.
Yeah, on the volume, since it was saying that the balloon was partly filled, that does not affect the volume. You just take it the way it is. You just compute. Yeah, is it the formula and you even go ahead or yeah.
Okay. So they said partly filled. So by partly filled, if you know, because sometimes we have to be also using what we know about balloons. We know that balloons, they inflate when you put air in it, right? So if you have put just a few small amount of air, it will have a certain volume. But if you put a lot of air in it, its volume will increase until it also has a maximum. There's also a certain point where the balloon can't take in any more air. So then if it reaches at that maximum, then it is fully filled. But if it doesn't reach at its maximum inflation, meaning it's partly filled. So that's why I said, forget about this word partly filled in any case, because air, the way it is, air, even if you put just small air in this, for example, in a room, if you even put just a small amount of air, it will fill the whole room because air moves everywhere. All right. So, like I said, just ignore this word partly filled, because if for example, but if they said maybe half filled, if they even use the word half, then would have used this, would have done the volume by half. Or if they said, if they gave us some figures, but since they just said partly filled, we don't need to consider it. We just need to take the volume like it is. We just know that by partly filled, it means the volume was not inflated to its maximum inflation.
All right, thank you.
Okay. I hope it's clear. So we have found the number of moles. Yeah. Now, what else are we going to find? The number of moles of the helium in the balloon and the mass of helium. So what does it tell you if you find the number of moles? What is the mass? So you know that number of moles is equals to mass given over the what? Molecular mass. All right. So as we need to find what? The mass in the helium. All right. So we need to find mass in the helium balloon. So meaning our mass will be equal to the number of moles multiplied by the molecular mass. All right. So I've found the number of moles is 43.67. And what is the molecular mass? Molecular mass is 4. All right. So the mass given, the mass that we're supposed to find is the number of moles 43.67 multiplied by 4, which is the molecular mass. Here you are lucky they have given you even the molecular mass. They have said helium He2, they even give you molecular mass is 4. But in other cases, you may need to even calculate the molecular mass of some elements. Sometimes they may even give you the periodic table, so you may be able to use the periodic table. I'm sure you know how to calculate molecular mass from chemistry. So this is how we are going to find the mass of the helium, just multiplying number of moles by the molecular mass. All right. So it's just that I don't have a calculator near here, would have found the actual answer. But this is something that you can also do. And in fact, I would like you to do it, as I will send you the OASIS. This document, I would need you to use the calculator and do justice. Just compute the number of moles given multiplied by the molecular mass using this formula. Number of moles is equals to the mass over molecular mass. Like that. Is that okay?
Yes, sir.
Yes, sir.
Yes. Yes.
Okay. Okay. So we continue. We have another question. Shall we have Kaoma to read for us this question?
Okay. It reads, a swimmer has 0.820 liter of dry air in his lungs when he dives into a lake. Assuming the pressure of the dry air inside his lungs is 95% of the external pressure at all times, what is the volume of the dry air in his lungs at a depth of 10 meters? Assume that the atmospheric pressure at the surface is 1.013 times 10 to the power 5 pascals.
Awesome. Thank you very much for reading. So we have a swimmer. Volume has been given in liters, and they dive into the lake. We know that the pressure of dry air is inside the lungs. And they have also told us something special, that assuming the pressure of the dry air inside the lungs is 95% of the external pressure at all times. So they have even given us this condition, 95. We'll see how are we going to use this idea of 95% of the external pressure. So again, they're asking us what the volume of, so that they are actually, the question is, what is the volume of dry air in his lungs at a depth of 10 meters. So we are talking about water. And we know that when we start going deeper in water, pressure increases. So from there, we can pick it up. So volume 1, this is the volume that they have. So obviously they are at the surface. All right. If this is a pond, this person, this person is on top, but then they go deeper. So they went deeper into the water. So like that. So at the top, they have this amount, 0.28 liters. And the pressure on top is due to atmospheric pressure. The pressure on top is due to atmospheric pressure, right? Yes. So here, they say that assume that the pressure in his lungs is 95% of the external pressure at all times. So if the pressure at the surface is atmospheric pressure, which is 1.013 times 10 to the power 5. So as we need to get the 95% of it, that's what we need to do. So no wonder we multiplied 0.95. 0.95 is because of the 95%. So multiplied by 0.95. to get the pressure in his lungs, because we are dealing with his lungs. It's the one that has that much volume. So this is how we got the volume. Volume 2, all right, is what we are actually asked to find. But pressure 2 at the bottom or at a certain height of 10 meters, pressure 2, we can be able to solve it. All right? Let's see how we can solve pressure 2. So pressure 2, since the pond, we are saying here there is atmosphere all over. All right? So even as he starts to go down, here we can also consider atmospheric pressure, because even here where he's down here, atmospheric pressure is still exerting on him. So we'll calculate the pressure due to this height, to this depth, and also we'll add atmospheric pressure to it, because in this case we need to, because we considered it. If we consider atmospheric pressure at the beginning, then even at the end we must consider it. That's what I said. So that's why we are adding atmospheric pressure to the picture. So we'll add the atmospheric pressure plus the pressure due to the depth, but we have to still get the 95% of it, because we were told at all times his pressure is 95% of the external pressure. So we know this is the atmospheric pressure, and this is how we can get pressure due to the depth of water. We know the density of water, we know acceleration due to gravity, we know the depth. So using this formula, we can calculate, and again, continuing by multiplying the 9.5, 0.95 there. All right, so we get the pressure 2, which is that Pascal. All right, because of course I should have shown that. The reason why we have found that is because we multiplied by this value here. I'll add it here. I didn't put it. I'll show it. I'll put it here. So we were multiplying also by 0.95. So from there now we can use this equation of saying P1 V1 is equals to P2 V2. We know P1, which is at the surface. We know the volume. Why are we not changing the volume? We can keep it as liters the way it is. I explained, I'm sure, that when using this formula, we can keep the units the way they are. And P2, we have just from calculating it. V2 is what we don't know. And using just math, we can find V2 as 0.4 of the liters. All right, 0.4 liters. This is the volume at the depth of 10 meters. So are we okay thus far with the solving?
Yes, sir.
Yeah.
Awesome. Awesome.
I've got a question.
Okay.
There, where it's written atmospheric pressure plus PG multiplied by 0.95. Why are we multiplying the things in the brackets by 0.95?
Okay, it's because we were told that the pressure of dry air inside his lungs is 95% of the pressure of the external pressure at all times. So the external pressure is what we have, the atmospheric pressure plus, this is not P, this is rho. This word is, this is not P, it's something like this. It's not like this. It's not P, it is bending like this. It is rho. So this is rho. It's a Greek letter called rho. And this is G, this is H, or we would have put D for depth, but we usually just put H like that. So we know that this is how we calculate for pressure due to the depth of a liquid. In this case, it is water. So the reason why we're multiplying by 9.5 is because we were told the pressure is 95% of the external pressure. Is that okay?
It is. Thank you.
So do we have anyone with a question so far? Okay. Otherwise, yeah, there are many questions on pressure. I'm sure you will find that out in the quiz. You will find that there are like a lot of questions. So, like I said, visit your more concept. Just try and find and just read a bit about moles if you have forgotten about how to find the number of moles, mass number, and whatnot. Yeah, you would need that concept. But since you learned it in chemistry, you should be warm and dry. And otherwise, in your notes, there's some other part which is talking about kinetic theory of gases. You know, you might read it. In fact, I encourage you to read it. But usually, with my experience, is that they never used to make reference to that part. You find that they would not make reference to it, whether in the test or in the quizzes or in anything. So I believe the quiz will only be about this information. It won't go to the kinetic theory of, but you can just read it for the sake of science, just reading. And also just in case they decide to bring it this time, but usually it doesn't have many calculations. It just has some theories, some science, so that you can just appreciate the science. Yeah, if by reading that stuff you find some questions, something that you're not understanding, you can still ask me. Yeah, you can still ask me. But otherwise, this is where we have ended our class today, if we don't have any other questions. So we have a homework still. Homework. Yeah, homework. Also, this homework has a bit of some. So you have seen pressures being given in terms of torr. So don't worry about this. Convey this unit torr. All you need to consider is if you are using this formula, just calculate. And I'm sure you should also know that if they give you to say V1 to V2, the ratio of V1 to V2 is the same as V1 over, oh sorry, it's the same as V1 over V2. So this, I hope this doesn't confuse you. You know, the ratio of 18 to 1. So yeah, you'll be able to see it and read it for yourself and solve it. Otherwise, have a wonderful evening and all the best in your life as you go about with life, and never forget about God, to pray and to read the Bible. Is that okay?
Thank you. Yes.
Thank you. And
Okay.
you too.
Okay, thank you. So have a good afternoon.